Welcome back, students, to one more session of a WOC, the topic of discussion today. In last video, I did the introduction part. Please watch that video. Right. So I have written some table here. Let us analyze what it is. So take your pen and write the heading today. The topic is bonding in carbon. Okay. So basically, when I say carbon, as I said, atomic number first I should know. Carbon, the symbol is C. The atomic number is 6. Correct. So here when I divide K shell, L shell, M shell and N shell, 2 and 4. This is the main concept. Here 4 is the particular number with which this 4, it tries to form 4 different bonds. It can form bond with carbon, or it can form a bond with carbon. It can form a bond with hydrogen. It can form with oxygen. It can form with fluorine. Why? Because there are 4 outermost electrons, valence electrons of 4. Now, because of this 4 or this one, we call carbon as which element? We call it as carbon as a tetravalent atom or tetravalent element. Okay, it has tetravalency. Tetra means 4, valent means outermost valence shell. Done. This is okay. Now, in bonding, when I see this data, as I said, this data is there in your NCERT textbook also. Just see. So here, what are you seeing? They have given me the data or the values of melting point and boiling point. They have picked up 1, 2, 3, 4 examples. What is the table teaching us? Let's see. See here, suppose there is one element. Let us take one element is like this. 3 boxes are there. That means the element is linked like this. C, C, C. Done. Here there is one more element like this. 1, 2. Okay, let us make only 2 here, and the third one let us try to pop up in the form of a window. Now how is it? This carbon is like this, and one more also we will draw like this. Now this is one type of carbon atoms linked. This is one variety of carbon atoms linked. Now this, for me, this is very easy. I can easily do the melting, or easily I can boil it, because one after the other I need to slice it and break and boil it. So it's easy to break. So the boiling point will be here. What? The boiling point will be less, because I can easily break with less boiling point only. I can start boiling it. I can break the bond here, here, here and boil it. But when it comes to this part, what is happening? There is something called stacking. Stacking means one after the other, one is fixed into the other. Because of this, what will happen? I require lot amount of energy to break this bond. Then I have to break this bond. Then I have to break this bond. Then I have to break this one, this one, this one. So when there is a stacking like this, one after the other, remember, it is difficult to break. When it is difficult to break, what will happen? Difficult to break. What will happen? Automatically the boiling point increases. Means I require a lot amount of energy to take, or if I have to just I use a lot of energy, then only break. That is what let us analyze here. Here what is happening? See here, acetic acid melting point is maximum 290, 391. It is maximum compared to everything. So first thing, if I take acetic, which is least, we will see. Methane melting point is 90 Kelvin and 111. Let us draw the structure and see. Suppose if I take acetic acid, same concept I am explaining here. Let us take here only. So here, this is this compound. Let us take methane. Structure is CH4, CHH, H4. Done. How much is this? This is methane is 90 Kelvin as well as 111 Kelvin. Right. Now, see here, the bonds are single, simple. It is only single bond. I'll break here, 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 here. I can boil it. When I take acetic acid, the structure is carbon is like this. Hydrogen is here. One more hydrogen. One more hydrogen. C is here. This one. C double bond O is here, done. Then single is there, then OH. Now see here, the bond, or here in this case, how many should I break? I have to break this bond, this one, this one, this one, this one, this one, this one. Isn't it stacked completely? Stacking? right? One after the other. That means when the stacking is more, when more and more bonds are inside, automatically melting point and boiling point increases. Remember. So that is the second point you need to remember. So I have understood carbon is tetravalent from here. Then I understood if it is a straight chain, simple bonds, I can easily say. So in this case, melting point and boiling point will be less. Done. In this case, when there is stacking like this compound, when I see, automatically melting and boiling point will be more. Shall we write for this CHCl3? Let us see whether stacking is there or not. So CHCl3, carbon is here, hydrogen is here, Cl. Little bit better, it is okay. Compared to this is little bit better. That's why the boiling point and melting point and boiling point have come down. Let us see one more. C2H5OH. C2, right? H5. So H3, 1, 2, 3, 2, 1, H5, OH. See, so many bonds I need to break. That's why the boiling point little bit, means compared to this it has come down, right? Now next thing, here again you see boiling point is more than this. Why? Because oxygen is here, I need to break this bond. So many bonds, that's why the boiling point is more. So when I see this concept, I think I have understood now. Let us summarize with this and come back to the next topic. So what will you write? You will write carbonates compounds if there is branching or if there is stacking. Let us write that here only. If there is stacking, then what will happen to melting and boiling point? Melting point and boiling point increases. This is fine? Yes. Okay. Now if there is, or if it is straight chain, what will happen? You can write melting point and boiling point decreases. Simple. Now we will come to next thing. Always remember, as I said, carbon requires how many electrons to become stable? It requires only 4 electrons. If it attains 4, what will happen? See here, then the configuration will become KLMN28. 28 means whose configuration? Okay ma'am, I don't know what is configuration, everything. Don't worry. Configuration is something just like your, you have your class roll number, just like that. Here what happens, the electrons in particular atom are divided into levels. K shell, L shell, just see here. Suppose this is the carbon atom. The center is nucleus. Here it has first shell, then it has second shell, it has third shell. Okay, right, let us write. So here KLM shells. Here the first shell, this is called K shell, this is called L, this is M, then N, O, P, Q. Right, this one is called the nucleus. Now what is the atomic number of carbon? 6. So in the nucleus there will be 6 protons and 6 neutrons, neutral charge. Now the electrons here are divided. In the K shell, how many are there? 2 electrons, 1 electron and 1 more electron. In the L shell, how many are there? 1 electron, 2 electrons, 3 electrons and 4 electrons. Now if carbon tries to gain 4 electrons, it will become 8 if it gains 8, correct? Right? So there will be an inert gas configuration. What is the number, atomic number of 10 inert gas? That is nothing but helium is 2. Helium, neon. So when it gains, it will get a configuration of neon. So what am I trying to explain? I am trying to explain that carbon will try to attain that 4 electrons or gain or lose. No, it is going to share. It's going to share this 4 electrons and it will form something called covalent bond. This is very important. As I said, no, carbon will never, I'll explain, it will never form C+4 cation. It will never form C-4. Why? We will learn just in 10 minutes. Right. So here, as I said, carbon is going to form covalent bond. That means it shares its electrons and they form a bond together. Now, why? What is the speciality? The speciality is, if carbon is forming a covalent bond, never it will form ions. We studied 3 varieties of bonds, isn't it? Ionic bond, covalent bond, coordinate covalent bond, correct? Ionic bond, transfer of electrons. We have watched it in the last chapter video. in metals and non-metals. Now covalent bond. In fourth chapter we'll be learning about covalent bond. So covalent bond means sharing of electrons, means one will share with other. Done. Now because of this covalent bond, they are non-conductors of electricity. Okay, graphite is conducting, non-conductors of electricity, that's different concept, that also I'll explain. Right, so the property, one more property. First thing, carbon is tetravalent. Second thing, stacking is there. Third thing, straight chain. Fourth thing, covalent bond, that's why they are non-conductors of electricity. Right, so many things I have learned now in bonding in carbon. Now the most important question or important part of this, let us erase everything and understand the concept. Now here if there will be a question asked to you all in bonding of carbon, what is that? Keep noting it. Does carbon form C-4 cation? Okay, what is the question? Let us write that. So question here important is, does carbon form C-4 anion or C+4 cation? Okay, ma'am, what is this cation, anion? I don't know. Okay, yes, I understand. Whenever something gains electrons, understand, whenever something gains electrons, then it forms anion. Whenever something loses electrons, it forms cation. Okay, I'll show you with an example. Right, now they're asking, will carbon form C-4 or C+4? Let us analyze that. Now, first condition, if I'll say, suppose if carbon gains 4 electrons, if it gains 4 electrons, what will happen? Right, let us see. Now, what is atomic number of carbon? Carbon is 6, correct? So K shell, L shell, M shell, N shell, 2, 4. Now they are saying carbon will gain 4 electrons from somewhere else. It tries to share bonds and gains 4 electrons. How it looks? Suppose if I take carbon atom like this, I have drawn the nucleus. So 6 atomic number means 6 protons and 6, yes, I'll just put the door. Okay, 6 protons and 6 neutrons. Done. Right, then I have to draw one shell, K shell, then I have to draw one more shell, L shell. Now how many electrons are there in K? There are 2 electrons, 1 electron and 1 more electron. In L shell, 1 electron, 1 more, 2, 3, 4. Now what did they say? They said it has gained. So sorry, the circle is not proper. I just did a rough thing. Okay, let me erase. It's not looking neat, but let me erase it and show you. Okay, so it doesn't have any electrons in L shell. I'm sorry. Okay, right. So here it has gained 4 electrons. So it has gained 4 electrons. So where will these 4 electrons go? They'll go to the outer shell. It will not go inside because inside is already stable. So how will it look? It will look 6 protons, 6 neutrons. So K shell, L shell. I'm sorry, the circles are not looking like circles, but right, no problem. So here in the K shell, this is your K shell. So 2 electrons are like that only. In the L shell, it has gained 4 electrons. Earlier it was 1, 2, 3, 4. Right? Now how many it has gained? 4. It will go here only. 1, 2, 3, 4 electrons. You see? Now let us compare. Now how many are there? How many? See, always remember the number of protons and the electrons should always balance. That is a concept. Protons and electrons, I accept. Sometimes it lacks, it will gain, it will lose, but it should not become bulkier. Now in this case, when it is gaining 4 electrons, how many protons? There are 6 protons. Correct? Now how many electrons? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh God. So how many electrons? 10 electrons. Now can carbon atom hold so many electrons? First of all, the size of the carbon atom is small. Can it hold 6 protons and 10 electrons? I said there should be a balance, isn't it? So it can't hold. That is why. So here what reason you should say? Carbon atom cannot hold 6 electrons towards 6 protons. Why I said? Here always proton proton is positive charge, electron is negative charge. It tries to drag, means always it tries the force of attraction. We call it as nuclear pull or nuclear charge or nuclear force of attraction. Here the nucleus will try to pull the electron always. Now proton number has become less, electrons have become more. Can it pull? Can it hold? No. What will you write? See here. Okay, one more thing. Here if it is gaining, I said gain is what? Anion. It will form C minus 4. Correct? Right. Now you will write, if carbon gains 4 electrons, correct? How many? Holding, or then it will be 6 protons and 10 electrons. You should write holding, this is important, holding 10 electrons against 6 protons is difficult, hence it does not form, what it does not form? C minus 4 anion. Right students, C minus 4 anion it will not form. Right. Now let us see the next condition. Right. So now we have seen carbon doesn't form C minus 4 anion. Now let us come to the next concept, that is, will carbon form C plus 4 cation? Plus means cation, isn't it? Right. Let us again see the same thing. Now I said carbon atom, atomic number 6. Let us draw. First is a nucleus. Okay. So in the nucleus you have 6 protons and you have 6 neutrons. Correct? You have the K shell, you have the L shell, you have the M shell. Okay. In the 6, first thing, K, L, M and N. 2, 4. So in the, this one, what do you say? In the K shell there are 2 electrons, 1 and 2. In the L shell, 1, 2, 3, 4 electrons are there. Now, what did they say? It is going to lose 4 electrons. Will carbon form C plus 4? Cation to form, it has to lose electrons. So here it is going to lose 4 electrons. Let us see how it looks. From where it is going to lose? It's going to lose electrons from the outermost shell only, here only. It will not go inside. Inside is stable. So when it loses, how does it look? Again, nucleus. This is the nucleus with 6 protons, 6 neutrons, and this is the K shell, this is the L shell, this is the M shell. Now, in the K shell, as usual, 2 electrons are still there because it is stable. Now, in the L shell, are there any electrons? This is gone, this is gone, this is gone, this is gone. Now see here, let us write. How many protons are there? There are 6 protons. How many electrons are there? 2 electrons. Now see. Now my condition is, I said it has to lose. What will I do? I'll go and I'll try to pull this electron outside. Will the nucleus keep quiet? No. When I am trying to pull this electron, nucleus, the proton is there, no, oppositely charged. Oppositely charged attract, isn't it? So the nucleus or the protons, they start attracting this electron towards it. It will not go and fall into the nucleus. It will be moving in circular orbitals only. But the force of attraction of the nucleus, because 6 is more than 2, isn't it? He'll try to pull the electrons towards it. Is it easy to take out that electron? 4 electrons? Very difficult. So that's why it will not form C plus 4 cation. What reason will I write? You should write, when carbon loses 4 electrons, then there exists how many protons? 6 protons whose force of attraction is more, and it is difficult to remove 2 electrons because it keeps pulling. That's why carbon doesn't form C minus 4. Now what is the conclusion? I understood carbon neither forms C plus 4 nor carbon either forms C minus 4. So what it forms, because it doesn't form ions, it is going to only prefer one type of bond, that is nothing but covalent bond. So it's going to form covalent bonds only, and we'll be still learning the covalent bond. That's nothing but sharing of the bond. So in the next video, we'll be learning the covalent bond, how you will form between atoms, how you're going to share. Very important video. It's a 3 marks question. Please come and watch the next video. And as of now, signing off. Thank you so much.